Good morning, dear students. So today we are going to learn one of the important topics in organic chemistry. That too from the chapter Some Basic Concepts of Organic Chemistry. Okay, in my previous lectures you might have learned the fundamentals, the introduction of organic chemistry. So today we are going to a specific topic, that is the nomenclature of organic compounds. Very important topic. Why I am saying this is we can say like our alphabets, basically in English we say. So if you know the alphabets, you will be able to frame words. Out of that you can frame sentences, correct? So similarly in organic chemistry also, if you want to learn any properties of any chapter or reactions, anything, first of all you should put a name to that particular stuff. So how you do that? So how we can learn that? Those things are what we are learning here. So this is the first and foremost thing that you should be able to understand. Then once you have understood this, how to name it and everything, then you will become comfortable. The basics are clear. Then we will go with the properties, analysis, what are the phenomena it will show. Then we will slowly step into each chapters and understand why these reactions. I can guarantee you that you don't want to by heart any reaction. You just want to learn the concepts, what are the expected reactions, why those reactions are happening. Just learn those fundamentals. Then you can itself say, sir, there can be a reaction like this. And when you look into the textbook and you can see the same reaction is present there. So this is the way usually I approach organic chemistry, and there are many fundamental books are also there. So I am not going to give a lecture on that. I will on the course I will inform you which and all things you need to learn or you want to read, so that you will get an extra curiosity or enthusiasm for this particular subject. Okay, I personally believe in chemistry the most interesting subject is organic chemistry, because this branch was a latest branch, I can say. Out of the inorganic and physical chemistry, inorganic chemistry was the first branch, and then comes the physical. Then I can say the latest was the organic. Why I am saying that is, in organic chemistry the latest, what and all things right now you are using detergents or what and all things, it's all derived. Pharmaceuticals, the entire area of pharmaceuticals, biomolecules, what is present inside our proteins, structures, everything, it is derived out of this organic chemistry only. So that's why this is a core topic for your medicine students, very important for medicine students, but engineering it's totally different. Okay, so that was just a brief introduction. So we will try to learn. So I can say generally, if you try to learn nomenclature means naming of organic compounds. We have three main systems. The first system is called trivial naming system, and it is also called common names. Okay, and the second one is called derived names. Okay, these two are different. So first one is the trivial naming system, and the second one is called derived naming system. And the third one, that is the most important, I can say, the most important, that is the IUPAC nomenclature or IUPAC naming system. So IUPAC, you know the full form, International Union for Pure and Applied Chemistry. So I will tell a small history based on this. Very simple. Initially when scientists, they discovered, the first organic compound that was synthesized in lab was urea, NH2CONH2, that was discovered by a German scientist named Wöhler in 1828. Okay. Now after that, they were initially, when they were discovering it, they don't know how to put the names of these organic compounds. So initially what they have chosen is, they will look into some of its properties, like from where it is invented, the source, maybe the name of the discoverer. Like that they chosen different things to put the name of the compound. One simple example is acetic acid. From vinegar it is derived. Okay, so these were the things they were looking into it. Okay, to put the name of the organic compound. And what was the problem for that is, later many organic compounds were discovered, and it was very difficult in and across different countries. They don't know what name have kept for this compound in some other country. In some other country it is different name, because the communication was not developed during that period. So finally IUPAC, they came into a conclusion that it is not possible that you put your name or some other name or something, that we propose some methods how to name an organic compound. That will be widely accepted. They come to this thought. But the problem here was many names were discovered by some people, and for them it's an ego issue basically. How can it is possible that we discovered something and it is some other body is coming and putting the names. So there come to be some tussle or fight was there, and they finally agreed that like those organic compounds which have their common names widely accepted. For example, something like phenol, benzene, all these names are widely accepted names. So we cannot change according to IUPAC. Instead, we follow the common names as the widely accepted IUPAC names. Okay, but any new organic compounds, organic compounds derived out of the fundamental stuffs, you can put the IUPAC name. So I will give you a clear idea when we go into each chapters which common names are accepted as widely accepted IUPAC names, and you should learn like that. And right now we will start with the concept of IUPAC nomenclature. That is very important for NEET as well as JEE, how to name it. Okay. Then we will go to my trivial or common naming system, and in between we will go to the derived name system. Okay. So I hope you got a fair introduction. Now we will go to our first topic in nomenclature, that is IUPAC naming system. Okay. So we will start with the concept IUPAC nomenclature. Okay. So here, coming to IUPAC nomenclature, we can say there are certain rules that will govern how to put the names. Okay. So broadly speaking, I may say there are two main rules that you should remember. Two main rules. And I can say under each main rule there are sub rules are there. Okay. So we will first say there are two main rules or two main steps. You can remember it like that. That is also okay. So two main rules. The first main rule is, you should remember the first one, that is the selection of longest continuous parent carbon chain. So here each term has a meaning and importance. So longest, very important, continuous, very very important, and parent, and very important, carbon chain. So all the four terms are important. So first rule is selection of longest continuous parent carbon chain, and I will explain you what is this. Don't worry, we will go in depth into this. Okay. And the next step is, after selecting the longest continuous parent carbon chain, the next step is numbering. Where you need to number, that is also very important. That is numbering, where in the selected parent carbon chain. So what you have selected as in the first step, that is the longest continuous parent carbon chain, that particular chain you need to number it. How to number that, and those things we will explain in detail. And what are the steps to remember while numbering? What are the rules to remember? All these will come under sub rules for this two. The first rule we have learned, and second step we learned. There will be sub rules for each step, step 1 as well as step 2. Okay, now we will learn in detail the step 1, that is the selection of longest continuous parent carbon chain. Okay. Okay. Listen, now we will go in detail what is the first sub rule that comes under the selection of longest continuous parent carbon chain. So the first sub rule under this states that you should select the longest continuous parent carbon chain containing functional group or multiple bond or substituents. Did you understand? I understood that you didn't understand. Okay, listen. So they are telling that always select the longest chain that should include either functional group, if functional group is present, or multiple bond if multiple bond is present, or substituents. That means if in your if in your organic compound, if functional group is present, then you should include the functional group mandatorily and then select the longest continuous chain. After including the functional group, find the largest possible longest continuous parent carbon chain. Suppose in your organic compound, if there is no functional group but multiple bonds are there, then the rule says that mandatorily you should include the multiple bonds, and mandatorily you should include, then find the With that you find the longest continuous parent carbon chain. And if that is not there, suppose substituents are there, in that case you should include them and then find the longest parent carbon chain. This is what it is saying. So this is not that easy when we say it actually. We will see with the different examples how this rule is understandable. Okay, so we will see different examples for that. Listen here. Okay, now if we look into this system, you can see a biggest chain has been seen. Every time the valency of carbon is 4. Okay, now how to number it? I know that as per my rule I should select the longest continuous chain that is possible. Okay, and if I see here, I know that this is a functional group. Okay, OH I know it is a functional group. But here you need to remember one thing. The rule says that always select the longest continuous parent carbon chain containing the functional group. Very important, the term containing. So that means you need to contain the carbon atom. You need to contain the carbon atom which is connected to the functional group. That is mandatory. And I know that there is no multiple bonds or other substituents are present. So the priority order is always, listen here. So if you see the priority order, okay. So if you have all these things present, the first priority it goes to FG. It stands for functional group. Then the priority goes to multiple bonds. Then the priority goes to number of carbon atoms, and then only it goes to substituents finally. Okay, now if you listen here, what is present here? Functional group is present, some substituents are present, and some number of carbon atoms are there. So priority finally goes to whom? Functional group. So I know this is my functional group, FG. This is my functional group. Correct. So as per the rule, I should include the carbon atom that is part of the functional group. That means functional group is connected to this carbon atom. So this carbon atom should mandatorily be included. Understood? And please look at the term. Always select the longest continuous parent. What chain? Carbon chain. That is also very important. That means they are asking you to select only the carbon chain. So whether can I include OH group into my longest chain? No. Instead, I should include the carbon atom which is connected to the OH group. Okay, since it is clearly mentioned carbon chain. So I am starting from here, my selection. I need to go continuously. Longest continuous. One continuously coming. Then up to here it is same. There is no deviations. So I will choose up to this as such. Then I can go in this way or I can go in this way, but both way it is same, because if here also one CH3, here also one CH3. So there is no difference. If you choose like this also, the name will be the same. If you choose this like, the name will be the same. We will see that there is no difference. So I can choose anything. So I will go for the straight one. Okay. So I have chosen the longest continuous parent carbon chain. Hope you understood how to select the longest continuous parent carbon chain. Okay, now we will see the next example, then it will become more clear. Okay. Okay, now we will see the next example. Now tell me here what are all things we need to look forward to. Now if you are looking at this compound, I can say there is a functional group present. Okay, super. And there is a multiple bond is present here. Okay, I could see a multiple bond also here. Now again I am going to the rule. The rule says that select the longest continuous parent carbon chain containing the functional group. So first priority goes to functional group. Okay, so functional group is this one, so that is connected to this one. So I should start from here. This I understood. Clear. Now I should select the longest continuous chain. So when I am going here, I can go in this way. So 1, 2, 3, 4. 4 you can go continuously. I can go in this way. That is 1, 2, 3, 4, 5. 5 I can go continuously. Or I can go in this way. 1, 2, 3, 4. Now here many students will prefer usually this path 1, 2, 3, 4, 5, and they will say, sir, that is having longest as well as continuous. But please remember here they are telling very clearly, always select the longest continuous parent carbon chain containing functional group or multiple bond or substituents. Okay, that means if it is possible to include a multiple bond also along with your parent carbon chain, you should mandatorily include that. Then only the preference goes to number of carbon atoms, because here if you count it has 5 carbon atoms, and here if you go in this way if you go, what will happen? Only 4 carbon atoms will come into picture. But here it has multiple bond. And now tell me who has preference, multiple bond or number of carbon atom has preference? We know that multiple bond has much preference than number of carbon atoms. So we need to mandatorily go through this way. And I can say this is my longest continuous parent carbon chain containing the functional group and multiple bond or substituents. Understood? So please understand why I went in this way, because here it has multiple bond and 4 carbon atoms, but if we go in the other way there is only 5 carbon atoms, and I know my preference is multiple bonds greater than the number of carbon atoms, then comes the substituents. So I should mandatorily go in this way. Understood? So this is my parent carbon chain. So this is what we learned as my first rule. So first rule says that always select the longest continuous parent carbon chain containing the functional group or multiple bond or substituents. Now we will go to the third example, that is also very important, different from first two. Okay, instead of going directly into the third example, that we will learn it as a next rule itself. Then it becomes easy for you to remember. Okay, so I will go to the next rule. That is the next sub rule. So please refer here the denotations. I have kept here 1. 1 stands for main rule and A stands for the first sub rule. So the next one will be 1B. Okay. So students, now we will go to the second sub rule. That is the second sub rule, that is first 1B. Now what this sub rule is stating to you? The rule says that if you have a carbon containing functional group is present, then include carbon of that functional group in the parent chain. Okay, I will elaborate in detail. So if you have a carbon containing functional group, that means there are 2 types of functional groups are present. There can be carbon containing functional group and functional group that does not contain carbon. For example, listen here. If you see here CHO, this you know it is an aldehyde group, and you know that this is where the linkage is happening with the carbon. So I can say this is a carbon containing functional group. And if you see this one COOH, this is carboxylic acid, oic acid, and this is also a carbon containing functional group, and with that only the linkage is happening. And this one you can see CONH2, that is an amide group, that is also having carbon, and that is where the linkage is happening. And you know C double bond O, that is the carbonyl group, and here also you know it's a carbon containing functional group. And next one COX, that is carbonyl halide, okay, or acyl halide, like that we used to say COX. So X stands for fluorine, chlorine, bromine or iodine, that is also a carbon containing functional group. And if you see in the last one, you could see carbonyl group C double bond O linked with oxygen, again a carbonyl group, and this group is called anhydride group, and this also have carbon present in the functional group. Now you have seen some functional group that contains carbon. Okay, and also you know there are functional group which does not contain carbon. For example, just now we have seen in my previous example OH group, correct, alcohol group, that does not have a carbon present in it. That okay, those are simple examples. OH group does not have a carbon. Amine, NH2 group, amine, does not have a carbon containing functional group. So this rule is valid only for functional groups that contain carbon. That is the most important thing to remember. Okay, now what the rule says, we will go through it one more time. If a carbon containing functional group is present, then what you need to do? Then include mandatorily, now they are saying mandatorily include carbon of that functional group in your parent chain. So when you are selecting the parent carbon chain, you need to include this functional group also. In the previous examples, you have seen that OH group was not included. Why? Because it does not have a carbon. Now the functional group, if it has a carbon, then you should mandatorily include this carbon also in your parent carbon chain. This is what the rule is stating. Okay, so I hope you got a rough idea. Okay, we will go through the examples and confirms this, or we will make it thorough. Okay, so we will go to the first example. Okay, so I have chosen here this as my first example. Now, how will you analyze this example? That is what is important. So I need to select a longest continuous parent carbon chain containing the functional group multiple bond or substituents, and I need also now to remember that if it is a carbon containing functional group, then I should include that carbon also, and I know that functional group has the highest priority. So first let me analyze whether a functional group is present there or not. So I understood that there is a functional group is present, that is my carboxylic acid group. Okay, so if functional group is present, that should get the highest priority. Now the next question is whether it is a carbon containing functional group or non-carbon containing functional group. I understood that it is a carbon containing functional group. Then very immediately you should remember this carbon should be now part of the parent chain, or this is where you need to start. So we know that this is a carbon containing functional group, and the rule says that we should mandatorily include this carbon in your parent carbon chain, and I know that the priority goes to functional group first. So it should start from where? It should start from here itself. Now the next question is in which direction you should go so that you will get the longest continuous parent carbon chain. If I go in this way, I know that 1, so this is common, 1, 2, 3. So 1, 2, 3, 4, 5. 5 length will become 5. And if I go in this way, 1, 2, 3, 4. If I go in this way, 1, 2, 3, 4. So I understood that this is my path. And please believe there is no multiple bonds or anything. So this should be my parent carbon chain. And please remember, if you are not knowing this rule, what is the problem? Many students will prefer which as the path. They will say 1, 2, 3, 4, 5, 6. There is 6 carbons are present. So this is my longest continuous parent carbon chain. And you know that is not correct, because if functional group is present, that we need to, first thing is if it is a carbon containing, you should include that carbon. If it is not a carbon containing functional group, then we should include the carbon atom that is connected to the functional group. Very, very important in your parent carbon chain. Okay. So I hope you understood this is my parent carbon chain. So how we have selected it. Now the same example we will see in another way. For example, now I am changing this. Okay. So see here, just I am rubbing, I am changing this in a way that now I am connecting a different functional group here for your better understanding. So I am connecting here OH group. Now tell me what will be my longest parent carbon chain. If you are able to say that, then you understood. Okay, so if you see here, I know that, okay, this is a functional group, I understood. But whether it is a carbon containing functional group? No. Then what the rule says that include the carbon that is connected to the functional group. So I know that this is that carbon which is connected to the functional group. So this carbon should be part of my parent carbon chain. It does not say that from here we need to start. It should be part of the parent carbon chain. Now I can select the longest parent carbon chain 1, 2, 3, 4, 5, 6, either in this way, or 1, 2, 3, 4, 5, 6, either in this way. Both way if you select it, you will get the same name. So I can say this is my parent carbon chain. Hope you understood the very important difference once it is a carbon containing or if it is not a carbon containing. If you have any other doubts, feel free to ask your doubts in our WhatsApp groups or in our doubt clearance sessions. Okay, So I hope this rule is clear and this example also you understood. Now we will see one more example to make it a little more clear. Okay. Okay, I hope you are able to see the example now. Now listen here. First question, how to select the longest continuous pair, how to do the longest continuous parent carbon chain selection. First thing to remember is go look for a functional group. I am looking for a functional group and I identified one functional group. This is present here. Okay, good. Now the next question over here is whether it is a carbon containing functional group or it is not a carbon containing functional group. I know it is a carbon containing. So I will start like this. Okay. Now the next thing is you need to select the longest continuous chain containing the double bonds or substituents. Now if I go in this way 1, 2, 3, 4, 5, I will get a 5 chain. If I go in this way 1, 2, 3, 4, 5, here also I will get a 5. If I go in this way 1, 2, 3, 4 is there. But remember that we know that multiple bond has a greater priority than number of carbon atoms. So you should include multiple bond in your parent carbon chain. So this will be my parent carbon chain. So I hope it is now very much clear for you. Okay. Now these two will behave like my substituents. This will be one substituent. Okay. And this will be another substituent. I hope the rule 1b is very much clear to you. We will go to the rule 1c. Okay. Okay, now we will go to our rule 1c, that is the third sub rule. This is one of the interesting rule, I should say. You can expect questions for NEET or JEE out of this actually. One of the interesting rule. First we will learn, try to read the statement. The statement states that if more than one, okay, if more than one equal chains of carbon are possible, if more than one equal chains of carbon are possible, then select the one which contains the maximum number of substituents. Okay, now I will explain. It is stating that suppose you have a compound that does not have any functional group, multiple bond or nothing is present, only single bonded compound, and if you are able to find identical length, for example in one route if you go there is 5, in another route if you go 5, another route if you go 5, so whatever route you are going 5, then you got a confusion because in all the route there are 5 carbon, then which path should be my parent carbon chain? This will be a doubt. So this will become clear with this example. Now if you see this compound, you can see here, if I take this path, okay, just I am taking this for your understanding. So if I am taking this as my path, okay, now see how many carbon atoms are there, 1, 2, 3. Okay, first of all please see there is no functional group or double bond in this compound. So if I am choosing this as my parent carbon chain, 1, 2, 3, 4, 5, 6 people, I mean 6 is my length. Okay, I hope it is clear. Now we will try to see another path. Okay, so that it becomes clear for you. Suppose I am taking this is my parent path, 1, 2, 3, this one. Okay, now if you see, you can select like this also, right? 1, 2, 3, 4, 5, 6. Again 6 is my path. So I understood this is also possible. Okay, now we will try to see the other one, some other path also. Okay, so okay, now suppose somebody has chosen a path like this. So this is also longest continuous, 1, 2, 3, 4, 5, 6. Again it is 6 only. So now this is the third, another possibility. You can find many possibilities, like 6 it is possible, and you know that all are 6. It is not going to 7 or any other highest number. So in all possible paths you are seeing 6 as the number. So that is what the rule is saying. If more than one equal chains of carbon are possible, so you could see here multiple ways. Another way you can see it like this. This is also possible. Now if you see here, This is the longest continuous parent carbon chain. 1, 2, 3, 4, 5, 6. This is also possible. Correct? Or some people will say it like this also. They will choose like this. Sir, this is also possible. They will choose like this. They will say, sir, this is also 1, 2, 3, 4, 5, 6. Correct? Again it is 6. So you have seen multiple paths. So in this case, which one you need to choose? This is the biggest question. You need to take an answer. So this rule will give you an answer to that question. Which one you should choose? Now the answer for that is, you could see here. Okay, so if you see the answer, then what they are telling, you should select the one which contains the maximum number of substituents. So what do you mean by maximum number of substituents? To make you understand a substituent, I will elaborate with one simple example. Listen here. Now if I take this compound, everybody know this is CH4. Is there any substituent here? You know that nothing. You know that carbon with the 4 hydrogen atoms, and one hydrogen atom, if I am replacing this with another chlorine, I know that there is one substituent K. Correct? So if I am putting one more replacing hydrogen atom with another chlorine, then I can say 2 substituent K. And if I am again going to replace with another chlorine, there are 3 substituents are there. And again if I am replacing, there is one more. So I can say maximum 4 substituents are possible for carbon atoms, since the valency of carbon is 4. So I understood 4 substituents. Now they are telling, when you choose the parent carbon chain, it should have if you have identical length, then choose a particular length which have the maximum number of substituents. So we will see that in detail. Suppose I am choosing this as my parent carbon chain. Okay. So this as my parent carbon chain. Now see how many substituents are here. Listen here. Now if this is my parent chain, if I am going like this, there is a substituent coming outside. So this is my first substituent. Now going up. So here I could see H. This is a parent chain. So there is outside one thing. So one H is replaced by this guy. So this is my another substituent. I can mark it as 2. Now if I am going again through the length, I could see here also one H is replaced by a substituent. So this is my third substituent. And if I am going here CH, again one more guy is here. So I can say this is my fourth substituent. Okay, so I hope you understood. So there are 4 substituents if I choose this as my parent carbon chain. Okay, now if I am choosing some other thing, okay, for example, for your understanding, if I am choosing some other thing as my parent carbon chain, now you can see the difference. Okay, we will see that, then it becomes very much clear for you. Okay, very, 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 very important, understanding this rule in a perfect way. Okay, I will rub this and we will try to choose some other path. While trying at home, please try different paths and calculate the number of substituents and choose that path which gives you the maximum number of substituents. Then that will be the answer. Okay, now I am going to choose another path for your understanding. So suppose I am choosing this as my parent chain. Listen here. So this is also 1, 2, 3, 4, 5, 6. Now tell me how many substituents are here. CH3, there is no substituent. CH2, there is no substituent. CH. So here there is a substituent. So I can say this is my first substituent. And again coming here CH. So this is my second substituent. So don't take this as substituents, because from here only one group, only one H is replaced. Here how many H should be there? CH2. So remaining one is here, and one bond is with the hydrogen, that is also present. So only one H is replaced by this substituent. Remaining are present in the parent chain. So that is why one substituent I am saying. Okay. So I can see here only 2 substituents are present. Okay. Now we will see another path. So this also I am rubbing. So this I am going in detail for your understanding. Otherwise this becomes confusion for you. Okay. So I am just rubbing and we will choose another path and we will count the number of substituents. So okay. So just I will put it more clear for you. CH. Okay. So let me choose another path, then you will get a fair idea, I hope. So I'm choosing. Okay. So now I am going to choose a path something like this. We have seen this earlier. Something like this. Okay. Now if you see here 1, 2, 3, 4, 5, 6. Now tell me how many substituents are here. Now if you see here, so this one, if I am going here CH, so this is my first substituent. 1H is replaced by this big group, and coming to here also 1H is replaced by this big group CH2 CH3, and coming here also 1H is replaced by CH3 group. So I can say again the number of substituents is 3 only, but again the parent carbon chain is having 6 carbon atoms. So that is the importance. So I can say this is also not my correct selection of parent carbon chain. So tell me which should be the correct selection, because here it is giving only 3 substituents. So I can say the one we have chosen with the 4 substituents, that is my parent carbon chain. So we will finally go to that, so that we will come to the right answer. Okay. So you can see. So I hope it is clear for you somehow. Please try to find all the possible pathways when you are trying at home, and try it out with a pencil so that it becomes easy for you to rub it and maybe do it. Or you have plenty of papers, I know. You just try it out. This is all about learning. When organic chemistry, when you learn it in this way, try to explore in all possible pathways, the chapter or the subject becomes very easy for you. I can assure you that. I used to teach in that way. So here, now, if I am choosing this as my parent carbon chain, okay, then I can say it has 4 substituents, because this is my first substituent, and this is my second substituent, and this is my third substituent, and this is my fourth substituent. Okay. So I hope this rule is clear for you. Now we will go to the 1D, that is the last sub rule under the main category, under the main category 1. So 1A is there, 1B is there, 1C is there, and last one is 1D. Okay, we will go to that.